Good afternoon, ladies and gentlemen. Welcome to our today's Brownbag-Session. Today, we are very happy to present you Miss Vanessa Berger. She's project coordinator here at our UNESCO chair team at Carinthia University of Applied Sciences, and she's also project coordinator at ECO, the Institute for Ecology in Klagenfurt. Today, she's talking about novel technologies in forest monitoring, which she also presented at the Sylvie Laser conference. So Vanessa, the question today is, how can we use digital twins in forest monitoring?
Thank you, Monica. It's nice that you're having me here, and welcome from my side. So I will start now with my presentation, and I hope you can see the slide soon. So my topic is how we can use digital twins in the forest monitoring, which is a really huge topic, not only so the digitization, not only in forest, also in other ecosystems and a lot of other sectors also. So I would like to introduce you a bit the methodology. So there are two different methods, laser scanning and photogrammetry. And then I would like to show you some examples from the National Park Gesäuse and Kalkalpen. At the Sylvie Laser conference, there we got a good overview of different technologies. So we are working at ECO for a long time with this airborne laser scanning from an airplane. Here we have a point density. So if we are talking about laser scanning, we talk about point density and point clouds. This means we try to get somehow reflections from the laser, and these then structure the ecosystem, so the forest, and the point density for airborne laser scanning is about more than 100 points per square meter. Then there's the airborne laser scanning from UAVs, where we have a bit higher point density, and the highest point density we can see at this terrestrial laser scanner. So for these, you can see here, this is the laser, and here also a camera, so that we have also RGB information about the point clouds. Then there are quite new technologies or newer approaches, which is this mobile laser scanning approach. In here, we have this backpack where you're walking through the forest with SLAM technology, which means that it's not that important that the GNSS, so that the GPS is correct. You're starting and walking a line and come back on your plot. And so the point cloud is generated. And with iPhone and iPads, you can also try out laser scanning on mobile devices. This is, I think, the cheapest version, because for all the others, we have more than 10,000. It's up to more than 100,000. That we get a short overview of what we expect from the data. So in here we have this airborne laser scanning, and here you can see this treetop detection. So if we have airborne laser scanning, we get a good overview about the crown height and how many trees we have here. We lose the information about this team. So we could not calculate an accurate estimation about the volume of such ALS. So this is then a calculation and not a correct, so more an estimation. When we use those dense laser scanning stripes, this means it's also airborne laser scanning, but you fly lower. So in here we have UAV and also airplanes, but they are flying 100 meters above the forest. For airborne laser scanning. For the normal one, you fly somehow at 700 meters above. And here down, we have this terrestrial laser scanning. Here we have about more than 10,000 points at the square meter. And here we can see we have a lot of information of the structure. We have good estimation and can measure the diameter of the stamps. We can also calculate steam curves. So in here, we get a lot of information about the lower part of the trees, but most of the time we are losing the information at the top. So for laser scanning, it's a good approach to have different methods. So to have once the airborne laser scanning to get a good overview of the crown, and the TLS to have all the information of gender stories and the themes. On the right side, we have here a plot we extracted from TLS. So if you work with such data, you want to select single trees. So do not only have the overview, you want to have single trees in there. And this is an example of some Picea avias. So in here, you can see the color indicates that these plots, so these points is one sample plot to one tree. There is another way to get information or digital twins from trees and forests, which is the photogrammetry motion. In here, we make a lot of pictures and then we try to calculate through the overlap of different pictures how the structure is built up. So in every picture, there is the information how far the object you see is. And if you have a lot of pictures, you can try to make also those point clouds. They are not so accurate, so the point clouds I made, but it's a good way to make it in a cheaper way. So on the left side, you can see a GoPro. So for forest monitoring, they tried out to go once around the plot, then second time go in the middle of the plot, and then make also pictures outside. And then in the program, the program take every photo and put together to these point clouds. We also work with such photogrammetric analysis with UAV, so ones from above to get the crowns, and also through the forest. On the left side, this is a forest we fly an UAV, so it was a normal Inspire, so no special technology, just pictures. And on the right side, there is a point cloud where the drone flew through the forest, which was a bit tricky. Then my question is, how can we use digital twins? So the usage, most of the time, we now use it for documentation. Because if we went in the forest and we tried to somehow assess the forest, the state of the forest, and biodiversity parameters, it's really hard to document it just on paper. So it's really good to have this documentation in 3D and not only one or two pictures. Then there's another thing, you can not only have the parameters extracted for a whole stand, you can have single trees. So a lot of information which are located on one tree, then you can extract the whole plot. So you have 10 or 20 meter diameter and can extract these and the stand level. Another important thing is for ground truthing, because if we all know, I think, a remote sensing product, so you have Sentinel, Landsat, and so on, and therefore you need also ground truthing. So you have to know what is out there, not only a picture from the satellite. And TLS especially is nowadays used as ground truthing because it's more accurate than if people are going out and write down how the tree looks like. And also for upscaling. So in Canada, for example, they use digital twins like these airborne laser scanning at a low flight height, and also TLS for to get a better overview of a few plots and then upscale it to the whole region. So you have a few parameters where you definitely know what's out there, and then you can use it and find some patterns also on the big satellite data. Then other parameters we get out of it. So it's the tree position. Until now, we're going out and we're trying to assess somehow the GPS position of trees, but it's not that easy if you are under the ground and the GPS is quite inaccurate. And if you have such laser scanning, you have tree positions. So you can also describe what is in the neighborhood of a tree. Is he affected from other trees? And then steam curves. So how is the steam? So also special microhabitats which appears out of these steam curves. And then tree height, tree structure, which means where does the crown begin? So, how is the crown structured? Then the diameter at any height. Normally we measure out there just at one height. With TLS, you can get it at any height. And therefore it's really good to have those parameters to measure then or to calculate then the tree volume, because all we use now are allometric functions. So you have one height and one diameter, but if you have the volume of the tree, then the biomass calculation is more accurate. And all these benchmarks showed us that the new technologies get a better biomass result than our old manual and allometric function biomass calculations. If you have a look on the stands, you can also see what is the stand structure. So is it just one layer, two layers, is it mixed or not? And also the number of trees in the forest. Here we have the national park. So on the side, you can see some standing trees, but also a lot of dead trees in there. This is now the crown height. In here, I can see that those trees are dead because they are looking quite different to these living trees down here. Here we have an example for segmentation. I'm sorry. And so we have the segments. So how is the forest structured? So where are the similar plots and segments? And then you can calculate the tree number and so on those segments. Here in the national park, Gesäuse, we tried out the change detection. So we used the newest data and then the data from 10 years ago. And here we can see that in the avalanche tracks, we have no, so green means we have higher biomass, red means we lose our biomass. So the red dots, here we see that the avalanche took away the trees, and the green, here we have a higher biomass, which means the trees were growing since the last 10 years. And also we used drone photos, so a new image to document the forest. Here you can see that the trees are lying, and they are lying in a direction like the avalanches. Then here's another example from the National Park Gesäuse. This is a terrestrial laser scanner. So it's On the left side, the laser scanner and an RGB information, and here only the photo and laser scanner.
Vanessa, thank you very much for your lecture. I hope it's getting better. Thank you very much for your attention. It was very inspiring. And I just asked the question in the team, do you have any questions?
Will ensure nature conservation in the 21st century. Be part of the new 4-semester part-time master program. Carinthia University of Applied Sciences.